this is a worked example on how to graph a monomial function with transformations. Um, so here we're given a function that we want to graph. It's 2 times x plus 1 cubed minus 1. And the first thing we want to do is we want to identify what the parent function is. And so the parent function is just the simplest monomial we can think of if we sort of remove all the extra values. So we get rid of the times 2, we get rid of the plus 1, we get rid of the minus 1. And the parent function that we're left with is going to be x cubed. And what we want to do from here is we want to choose some sample points because we will use our method of transformations on each of the sample points. Now, the good thing about monomial functions is that the sample points you pick don't really change for higher order functions. So the examples I provided in the worksheet for an odd function are the following sample points. So we'll pick -1, -1, we'll pick 0, 0, and we'll pick 1, 1. And this really wouldn't change for higher order functions. Like if, for example, my parent function, well, I'll put a little star because it's not my actual parent function. If my parent function was x to some very large odd number, let's say 33 instead of just 3, I could actually use the same exact sample points. It's just going to sharpen the curve that the function has. Now, don't worry too much about this right now. You're just concerned about this more basic example. So, what we can do is we can make a table, and in this table, we can write down our points. So here are my points P, and I can put down -1, -1, 0, 0, and 1, 1. Then I want to add more columns because if you look at theorem 2.1, we have 3 calculations we have to make. We have to identify what h is and add that to the x values. You have to identify what a is and multiply that by the y values. You have to identify what k is. So let's just go ahead and do this in each column. Sorry, that is completely out of order. But let's go ahead and do this. So h, a, and k. And if we go ahead and identify these values, we can calculate them all at each instance on the table. It makes it a lot easier. So our h value in this case is going to be, and you want to be careful here, it's going to be -1. And this is because in our actual function, right, we have this term x plus 1 cubed. Well, if you remember the formula, a times x minus h to the n plus k, h is negative in this instance. And so I want to pick an h value that would return a +1. And the only way we get that is if we subtract a -1, that turns into x plus a +1. So h in our case is -1, so you want to be careful about that. The rest are a lot easier, so a is going to be 2, and k is going to be -1. Okay, so now we can go through each of our series of points, and we can do the operation based on the theorem from the textbook. So for h, our guide says that we want to add h to every x value. So I can go down my list of sample points, and I'm going to add that -1 or subtract 1 to all of my x values. So here, -1 becomes -2 because we're subtracting 1. 0 becomes -1, and 1 becomes 0. So all I did in this instance is I just subtracted 1 from all those x values. The next step is to multiply all my y values by a. So a is 2 in this instance, so -2 times +2 is -4. Or I'm so sorry. We are actually doing this to our y values. So -1 times 2 is -2. And then 0 times 2 is 0, and 1 times 2 is 2. So yeah, you're multiplying a by all of the y values. And then finally you want to add k to each of your x values. Or, I'm messing up again, each of your new y values. So -2, I have -2 plus -1 is -3. I have 0 plus a -1 is -1, and 2 plus a -1 is 1. And so now what we have done is we started with a series of sample points, and we transformed them into a new list of points that we can now draw on a graph and trace to get a more complete image of the function. So let's go ahead and actually do that. So let me make a little bit of room so my face cam doesn't get in the way. But we can go ahead and draw out our graph. Okay, so how many tick marks do I want? I probably want 3 in each direction. Okay, and so let's just draw our points out and then we'll trace the function through. It is useful to sort of know what each parent function looks like, but you can check the worksheet for that as well. So our first point is at -2, -3, so I'll have a point right around here. My next point is at -1, -1, so it's going to be right here. And then my next point is at 0, 1. And so this does look like a straight line, but what I mean by it's good to know what the parent function looks like is we're working with a parent function of x cubed. And so I want to keep in mind that this is going to look like a sort of thunderbolt. I don't even know what to call that thing, but it's going to look like this on the graph. And so when I trace this out on my plane, I want to keep in mind that I'm not just drawing a straight line. We're actually tracing through x to the power of 3. And so we can kind of draw that shape like so. And that's basically it. That is how you would take a function with transformations and identify the parent function and turn that into a graph.